going to identify symmetric figures as well as recognize that some shapes have more than one line of symmetry. Let's first discuss what are symmetric figures. When a two-dimensional figure can be folded along a line and create a matching part, the figure is symmetric. So let's begin by looking at this heart over here. I can create two matching parts if I were to fold or cut the heart down the center like this. It kind of reminds me of wings on a butterfly. So if I were to cut it down the center, now I can visually see, wow, I have two equal parts over here. And I can fold it over just like this. Okay? So this vertical line that we created, we call its line of symmetry. So because this heart has at least one line of symmetry, this shape is symmetrical, and its line of symmetry just happens to be a vertical line. Let's take a look at the letter C. Now with the heart shape, we were able to make a fold down the center like this. But if we were to fold the C down the center like we did for the heart, we would not create matching parts. They wouldn't be equal. However, I see that I can fold the top part of the C over the bottom part of the C. Just like this. Here, I have created a horizontal fold, or we can call it a horizontal cut, where I would be taking the top part of the C and folding it over the bottom of the C. Now, even though the direction of the line of symmetry here is horizontal instead of vertical, the shape still has at least one line of symmetry, making this shape symmetrical, the square. Now, if we take a look at the square, I can see that I can make a vertical cut like we did with the heart. So here's my vertical cut. So I can fold this part over this part, and I will have matching or equal parts. They're also called mirror views. It's like a reflection, as if you were to look in the mirror. We can take a look at what we did for the letter C. For the letter C, I made a horizontal cut. Now if I make a horizontal cut or fold on my square, once again, I can see that I can take my top section, fold it over the bottom section, and I have another set of equal parts. So right now our square has two lines of symmetry. Now you might be thinking to yourself, well, I think there's one more, or maybe even two more lines of symmetry that I can make on my square. If I were to take my square and fold it from corner to corner, so essentially I'm making diagonal folds, once again, I would be creating equal parts. So I'm taking this corner, folding it over to this corner, and this corner, folding it over to this corner. It's very similar as to making a paper snowflake when you take the square and fold it and connect the corners. So you might be able to recognize now that some shapes have just one line of symmetry, and some shapes have more than one line of symmetry. So this square is also definitely symmetric. Now let's take a look at the letter P. So hopefully from the first three examples that we did, we can quickly observe this letter or figure and determine if it is symmetric or if it has any lines of symmetry. So let's start by trying a vertical line of symmetry. Now if I use a vertical line of symmetry, which means I'm folding this side over this side, I'm not going to be creating equal parts. If I try a horizontal line of symmetry, where I'm taking the top part, folding over to the bottom, once again, I'm not getting matching parts. So it's not symmetrical going horizontally. Now we can try our diagonal lines like we did on the square, and once again, I can already see that if I were to fold it over these lines, I'm not going to get any equal or matching parts. So this letter P is not symmetric. It does not have any lines of symmetry. Before we get to our conclusion, there is one shape that its symmetry is infinite, which means it has infinite lines of symmetry. Can you guess what the shape is? So right now is a good opportunity to pause the video, turn and talk with your classmates, and see if you can figure out what this shape is. Now, if you guess a circle, then you are correct. Since there are an infinite number of lines through the center of a circle, the circle has an infinite number of lines of symmetry. So the circle is a very special two-dimensional shape when it comes to lines of symmetry. So in conclusion, a shape may have one line of symmetry, many lines of symmetry, or no lines of symmetry at all. Those shapes that can be folded down a line and create equal or matching parts are symmetric.